In this video, we are going to be discussing the example problem 2.5. It's right after Raoult's law in your textbooks. So, vapor pressure of chloroform and dichloromethane at 290 Kelvin are 200 millimeters of Hg and 415 Hg, respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 grams of chloroform and 40 grams of dichloromethane at 298 Kelvin. And we also need to calculate the mole fractions of each of these components. So we need to find out the vapor pressure of a solution as well as the mole fraction of the components of this particular solution. So first of all, let's write down what's been given to us. So first is the vapor pressure of CHCl₃, which is chloroform. So I'm going to say P naught CHCl₃. Okay, and this at 298 Kelvin is 200 mmHg. Okay, the next thing that's been given to us is the vapor pressure of CH₂Cl₂, which is dichloromethane. P naught CH₂Cl₂ will be equal to 415 mmHg. Okay, so we need to calculate the vapor pressure of the solution. So basically from Raoult's law, we know P equals to, or P total equals to P naught, P1 naught, let's say this is the equation in your textbooks. So P1 naught plus P2 naught minus P1 naught into x2. This is the equation of Raoult's law, and we basically want to find out the value of P total for this particular solution. Okay, now we have the value of P1 naught and P2 naught respectively. That is the vapor pressures of dichloromethane and chloroform. We have both those values. However, we do not have the value of the mole fraction of one of the components or both of the components. Basically, we don't have the mole fraction. So we have been given the quantities of the chloroform and the dichloromethane. So we have been given mass of, actually I should have written it up there, but oh well. So we have been given the mass of CHCl₃, which is chloroform. So this is equal to 25 point, where is it? Okay, here, 25.5 grams. Okay, we've also been given the mass of dichloromethane, which is CH₂Cl₂, which is here 40 grams. Okay, so we've been given the masses of both of these components. So from the masses, we can calculate the number of moles, right? So the number of moles, oh, sorry. Okay, so number of moles, pretty sure you should know this equation by now, is mass divided by molar mass. Right, so we can calculate the molar mass. So how do we do that? First of all, molar mass of CHCl₃, which is chloroform, is equal to carbon's mass, which is 12, plus 1 atom of hydrogen, which is 1, plus Cl₃, which is 35.5 into 3 times. So basically, we are taking the masses of individual atoms, right? So you should be able to find it in a periodic table anywhere, right? So the molar mass for this would be basically all of this total. When we add all of this, we get 119.5 grams per mole, because molar mass, because the number of moles in per gram, right? Next is the molar mass of dichloromethane, which is CH₂Cl₂, will be equal to 12 plus 2. 1 into 2, because you have 2 atoms of hydrogen, and then you have 35.5 into 2. So this, when simplified, will give us 85 grams per mole. Now we can calculate the number of moles of each of these substances. So number of moles N of CH2, sorry, let's start with the first one, CH3Cl. Okay. Oh, sorry. I am so sorry. CHCl₃ is equal to, that is the mass, which is 25.5 grams, divided by 119.5 grams per mole. So gram and gram gets cancelled, mole gets transferred to the top, so you get moles. Now when you simplify 25.5 divided by 119.5, you get 0.213 moles. Okay, the next one would obviously be for dichloromethane. So NCH2Cl2 is equal to 40 grams divided by 85 grams per mole. And then this, when simplified, you get 0.471 moles. Okay, basically what we're trying to do right now is we are trying to get the mole fraction, right? And to calculate the mole fraction, you need the values of the number of moles of each of these components. So you have the value of number of moles of chloroform is 0.213, and for dichloromethane is 0.471. So now we can calculate the mole fraction. Let me scroll down a little bit. So the mole fraction formula is X of A will be equal to Na divided by Na plus Nb. And Xb will be equal to, and we are assuming this is for a solution that contains two components. So Nb divided by Na plus Nb. Okay, so using the same equation, we obviously need the total number of moles. So let's first calculate the total number of moles to make it a little easier. So the total number of moles will be equal to 0.213 plus 0.471 moles. And this will be equal to, this total is 0.684 moles. Now, this is the total number of moles in the solution. From here, we can calculate the mole fraction. Honestly, you just need one of them, but I'm going to be showing you a calculation of both of them, and you can use just one of them to do the math to calculate the value of P total. Okay, you can use either as long as you apply the equation correctly. So let's calculate the mole fraction of CHCl₃, which is equal to the number of moles of CHCl₃, which is 0.213 moles, divided by 0.684 moles. And obviously this gets cancelled, and mole fraction does not have a unit. We did discuss that in the beginning of this chapter, and this, when simplified, gives us 0.311. Now you can either do 1 minus 0.311 to get the value of CH2Cl2, or you can actually calculate it, whichever is easy. Personally, I think subtracting 1 is easier, because in the end of the day, the total mole fraction for a particular solution is going to be equal to 1. But I'm just going to show it with like dividing it. So 0.471 moles divided by 0.684 moles. Again, mole and mole gets cancelled, giving us the mole fraction of dichloromethane as 0.689. Okay, so this is the mole fraction of both dichloromethane and chloroform. Now we just need to use this particular equation in the right manner for us to get the values. So I'm going to quickly add the values of the mole fractions over here. So X of CH₂Cl₂ will be equal to 0.689, and X of CHCl₃, keep making that mistake. Okay, CHCl₃ is equal to 0.311. So we have all of these values. Okay, so I'm just going to rewrite this particular equation over here. Okay, so we have P total, which is going to be the vapor pressure of the solution, is equal to P1 naught plus P2 naught minus P1 naught whole into X2. Okay, so P1 naught plus, we're basically using this equation, but we will be writing the values of CHCl₃ and dichloromethane. So P total is equal to P CHCl₃ naught plus P CH₂Cl₂ minus P naught CHCl₃ whole into mole fraction of the second component, which is CH₂Cl₂. Okay, so the next thing, we are just going to have to substitute all of these values. So you'll have 200 plus 415 minus 200 into the mole fraction of CH₂Cl₂, which is 0.689. This gives us 200 plus 215 into 0.689, which is equal to 200 plus 148.135, and this gives us 348.135 mmHg. And the reason I didn't talk about units much for this one is because you have all your units of the pressure, which is going to be mmHg all throughout, and the mole fraction is not going to have any units. Basically, for this question, for the first part of this question at least, we basically were able to calculate the total vapor pressure of the solution by using the, by So we were able to calculate the vapor pressure of the solution by using the mole we started with calculating by the number of moles using the mass and the molar mass of each of these compounds, and then we were able to calculate the mole fraction of the individual components. From that, we were able to then substitute it into this equation for us to obtain the value of the pressure of the solution. The next part of the question is mole fraction of each of these components in the vapor pressure. So basically, you have an equation given in your textbook. So we have the equation given in the textbook as P1 equals to Y1 into P total. So we need to calculate the value of Y1, where Y1 is the mole fraction of the component in the vapor phase. So basically, we can say that we can calculate the value of the pressure of the individual components as using the equation P naught into X, right? P equals to P naught X. So P of the pressure of CHCl₃ will be equal to P naught, which is this value. So 200, and this has been given the beginning of the question. So 200 mmHg into the mole fraction, which is 0.311. And this gives us the value of the pressure of the particular component, which is 62.2 mmHg. The next one will be obviously for the dichloromethane, CH₂Cl₂ equals to 415 mmHg into the mole fraction, which is 0.689, which is again equal to 285.9 mmHg. And we have the vapor pressure, the total P total. So P total equals to 348.135 mmHg. So we just have to use these values and calculate the mole fraction in the vapor phase. Basically, it's just substituting it in the equation. So Y of CHCl₃ will be equal to P total, which is equal to 348.135 mm. Oh, I'm sorry. Let me write the equation here for myself. So Y will be equal to P1 divided by P total. So YCHCl₃ will be equal to P of CHCl₃, which is 62.2 mmHg divided by 348.135 mmHg. This gets cancelled, so you don't have any units for the mole fraction, and we get 0.179. Basically, when we simplify this, we get the value 0.179. Similarly, we can calculate YCH₂Cl₂ will be equal to 285.9 mm divided by 348.135 mm of Hg, and then both these units will again get cancelled, and when this gets simplified you get 0.821. So basically we use the equation P1 equals to Y1 into P total, where Y1 is the mole fraction of the component in the vapor phase, to get the values of the mole fractions, because we have the value of P1, which can be calculated using the total vapor pressure, like using the vapor pressure of the component, pure component, and the mole fraction of that particular component in the solution. We were able to calculate the value of P, and then we were able to calculate the value of the mole fraction of the component in the vapor phase. With that, we're done with this example problem. In the next video, we will be continuing with the example problems.